but we're going to look at finding where two lines meet. Where the two lines meet. And we have different ways to find where two lines meet. So I want to show you the different methods. Two lines will always meet unless they are what? When will two lines not meet? Parallel. So except for this situation, two lines should always meet. Except when they're parallel. And we have 4 different methods I want to show you to find where two lines meet. But only 2 of the methods you actually need really for the exam. But you can use, you can use whatever method you want, unless the question says use a certain method. So I'll show you the 4 different methods. So this lesson, there's not as much to do. I just have 4 things to show you, and then we can practice. So I call this now degree 2 system. Now listen. So these are problems when you have 2 lines and you want to find where they meet, like this. So we have 4 methods. The first method is what you might call a graphical method. And you could probably guess what this method means from the name. You draw it. Of course, this isn't a good method for the exam, but sometimes they ask you to draw it. So let's have a look at an example. I want to know where does this line meet and this line. So in other words, I want you to solve this system. So we have to draw it. This is the way we'll do it. Can I scroll down a little bit? Yeah. Okay. Yeah. Okay, so let's find out where the roots are. If we say let y equals 0, we get minus 6x plus 3 equals 0. So x equals, I'm looking at the first one, yeah? So, a half, isn't it? Minus 3 over minus 6. So a half. Yeah. And in the other case, I get minus 9x plus 3 equals 0. So that means x equals a third. 1/3, yeah. Yeah? Okay, so let's try and draw this now. Now because x is quite small, I'll make this 1. And I think y will be bigger, so I'll make this like 4. 2, 1 and 3. And that's 0, of course. And that's y, and that's x. So for the first line, it has a root at a half. And a y-intercept at 3. Now you should start seeing what's going to happen here. The second one has a root at, well, let me just draw that in first. The second one has a root at 1/3, but then you realize, oh wait, it also has a y-intercept of 3, doesn't it? Yeah. So this is actually a very easy one because you can clearly see that they meet here at 0, 3. Yeah. But like I said, this isn't really the best way to do them because you could easily make a mistake in your graph. So the second method is the first method that's really useful for the exam. And it's probably the method you learned in high school. So let's have a look at the second method. Can I scroll down? Yeah. So the second method, substitution. So I'll just make up an example. I'll just say 2x plus 3y equals 5, and then we'll say something like 2x plus y equals 3. So in this, questions? Yeah. Oh no, no question, okay. So in the substitution method, what you do is you make y the subject for one of them. It doesn't matter which. Let's choose this one. So if I make y the subject, yeah, y equals 3 minus 2x. And then you substitute, yeah, you put in to the first one. So now you have 2x plus 3y, which is 3 minus 2x, equals 5. So it's like you've substituted this y for this, because it's also equal to y. Now, expanding, we have 9 minus 6x equals 5. 6x minus 2x, and then 9 minus 5. 4 equals 4x, so obviously x equals 1. But we still need to get y. Yeah. Original. Yeah. So by using x equals 1 into this, we can say y equals also 1 then. So this is the answer here. And this is the substitution method. We have two more methods. So write this one down, and then we'll go on to the next method, method 3 then. So this is the substitution method. And you should learn the names of these methods, because in the exam it might say, use the method. Substitution, graphical, whatever. If they don't say what method to use, you can use any method. As long as you get the right answer, it's fine. Okay. Can I go on, or do you need time? Bruce? No, are you sure? Sure? Okay. Next method. Method 3. Elimination method. So this method, let's take an example. Minus 7x minus 9y equals 1, minus x minus 2y equals 8. So this method you probably have seen in high school as well. It's when you want to make the x's or the y's the same, and then you can cancel them. And you can choose either x or y. So I think for me it looks easier to do x, yeah, because if you multiply this by 7, now they're the same. So you have minus 7x minus 9y equals 1, and minus 7x plus 14y, what's that, 58? 56, what is 56? Right, 56. So now they're the same. Next, you can choose to add or subtract. So should we add or subtract? Subtract. We subtract now. Minus 7x minus 7x, gone, 0. Minus 9y minus 14y is minus 23y. And then 1 minus 56 is minus 55. Yeah?
Yeah.
I feel like something went wrong. Well, I haven't...
The second, it could be minus 14. Minus 14y.
Yeah, minus 14.
Yeah, what's up with this? Disgraceful. Disgraceful. Minus. I totally changed it now, because that's going to be minus 9 minus 14, which is minus 9 plus 14, which is 5, which is much better.
Yeah.
Because now I actually get a nice answer. Y equals 11, yeah. But I still need to find the x. So what can I do to get the x? Yeah, now which one? You have 4 choices. You can use A, B, C, or D. Oh, you can use any, but B is definitely the best one because it has the smallest numbers in it. Yeah, yes. So I have minus x plus 22 equals 8. So I get x equals 22 minus 8. Yeah? No? Correct? 22 minus 8? Yeah, which is 14?
Yeah, 14.
So my answer is x is 14 and y is minus 11. Now, am I right in thinking this is how you learned how to do it in high school? Probably this way. Yeah. Okay, I have another method to show you, and maybe someone has seen it before, but I think most people have not seen the next method. So you'll need to pay close attention for the next one. Can I scroll down? Do you have this? Yep. Okay. Method 4.
Oh.
Now you see, some people have seen this before. Contain your excitement. Gaussian method for the last one. Now this method works very well for very difficult, messy problems. So I'll show you an easy one first, and then I'll do a difficult one second. So let's do an easy one first. In fact, let's do the one we just did a moment ago. So can you just read, what was that? Minus 7x?
Minus 7x minus 9y.
Yeah, equals 1. And then the next one?
Minus
8x?
X.
Oh, minus x, yeah.
Minus 2y.
Yeah.
Equals 8.
Okay. So let me show you this method. What you do first is you make a block of the numbers, like this. Minus 7, minus 9, dot, 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 1.
I hate this one. I think it's so much.
Minus 1, minus 2, and 8 then.
That's very ugly.
Yeah. Now, some people have studied another method which they might be thinking, oh, I know this. This is not the matrix method. Okay, this is not the matrix method. Okay, it's not this one. Right, so there's 3 rules here. First rule is you can swap the rows if you want. So you can swap these if you want. That's the first rule. The second rule is you can multiply a row by any number except 0. Because if you use 0, then it's 0, 0, 0, which is no good. And last rule is you can add or subtract 2 rows and then put the answer on either row. So for example, you could do this row plus this row and then put the answer on this one. And let me show you with an example, okay? So what we'll do first is we'll try and make these the same. So I'll multiply this by 7. So I have minus 7, minus 9, 1, minus 7, minus 14, 56. Now, so if you want, you could write it here on the side. Let me write that there. I took row 2 and I multiplied it by 7. Now what I'll do next is I'll do row 1 minus row 2 and I'll put the answer on row 2. Very good. Watch what happens. So the first row stays the same. Yeah. Minus 7 minus minus 7.
0.
Minus 9
Five.
minus 14 is 5, and then this one is minus 55. Okay, now I want to try and make these the same.
Yeah.
What will I do? I'll do row 1 multiplied by 5, yeah. Row 2 multiplied by 9. Calculator's ready. This will be minus 35 minus 45 5 0 45 something.
495.
495, thank you. With a minus.
Yeah.
Now next I'll do row 1 plus row 2 and put the answer on no, row 1.
Oh.
So row 2 is the same now. Minus 35 plus 0
Minus
35.
That is easy.
minus 45 plus 45
0.
5 and minus 495 is minus 490, isn't it?
Yeah.
Finally, I'll do row 1 multiplied by minus 1 over 35 and row 2 multiplied by 1 over 45. So then I'm left with 1, 0, and a number, please. Could someone tell me? What is it?
14.
Yeah, 14.
And then the second one?
11.
11, is it? I feel like I
With the
did
minus.
Minus 11.
with the minus here.
Yeah.
Yeah?
Yeah.
I think I feel like I made a mistake.
Believe.
Believe?
Yeah, believe.
No, I can't believe. I have no faith. I do believe! Yes, sorry. It is correct. Good. So, if you were to rewrite this, if you think about what you've just done, let's change these back into their equation form. So the first one would be 1x plus 0y equals 14. In other words, x equals 14. And this one is y equals 14. Y equals minus 11.
Yeah.
So basically this here is the answer. If you can get these numbers here, 1, 0, 0, 1. Now I know this method seemed very long, and it was very long for this question, because this question is a simple question. But later in the year, when you have questions like this, when you have 3 of them, then this method works really well. Now, some people don't believe me. You should just believe those. I think we'll do one more example of this. Okay. To convince you of its benefits, I will use it for XYZ question with 3 of them. Can I scroll down? Yeah. Okay, so we'll say x plus 2y plus z equals 4. 2x minus 2y plus z equals 1. And we'll say x minus y minus z equals, minus 1. Okay, let's use the Gaussian method for this one. Can I start it?
Yeah.
Yep. Okay, so we have 1, 2, 1, 4, 2, minus 2, 1, 1, 1, minus 1, minus 1, minus 1. Okay, let's see what happens. I will multiply this by 2 and multiply this by 2.
Yeah.
So now I have 2, 4, 2, 8. And the same.
Yeah.
2 minus 2 minus 2 minus 2. Okay. Now, I'll do row 1 minus row 2, and I'll put the answer on 2. And I'll do row 1 minus row 3, and put the answer on 3.
Okay.
So which row stays the same?
Row
Only row 1 stays the same here. 2, 4, 2, 8. Okay, 1 minus 2. 0, 8, 6. Thank you. 1 and 7. And then row 1 minus 3. 0, 6, 4, 10.
10.
Great. Great. Okay. Next I will do row 2 minus row 3 and put the answer on 3. So, which is staying the same here? 1 and 2, aren't they? 2, 4, 2, 8, 0, 6, 1, 7. Okay. 0, 0, minus 3, minus 3. Okay. Now, next I'll do this row. That's a 0, by the way. No, that's a 6. Okay. I'll do this row. Yeah, divided by or multiplied by minus 1 over 3. This row I'll do divided by 6. And this one here, I'll write divide because that's neater. Divide by minus 3, divide by 6, divide by 2. So now I have 1, 2, 1, 4. 0, 1, 1 over 6, 7 over 6. And then 0, 0, 1, 1. And this is actually practically finished. Because if you think about now what you have, by making the zeros here, the last equation is what? Z equals 1. The second last equation is y plus a 6th z equals 7 over 6. But, you know z.
Equal 1.
Yeah, it's equal to 1.
Yeah.
So y would equal 7 6 minus 1 6, which is 1. So y equals 1. And then if you look at the first equation, you have x plus
2y
plus z.
z.
But you know y and z.
Yeah.
So you have x plus 2 plus 1 equals 4. So x equals 1 here. Am I starting to make you believe
Somewhat.
this is a good way
Yeah.
Yes.
for this?
I think to use another way is more simple than this.
You don't like this method? I like this method.
Okay.
Okay, personal taste. So, when you have big problems, if you can make it into this form, 0, 0, 0, yeah. This would be, for example, x, y, z, w even. If you can get a triangle of zeros, then this one gives you one of, this gives you an answer, and then you take that answer and you put it here, you get the next answer, you get the next answer, and the next answer. So your goal is to make this triangle of zeros, and then you're finished. It is interesting, isn't it? At least I think so too. The good news is, in the exam, they never ask for this method. So I just showed you it for your general health and education. Very, very healthy, very healthy. So, the most important method for the exam is substitution and elimination. So the questions I want you to try I want you to do 1A, 2 AB, 3 AB, and 4A. So A, AB, AB, and A then. Yeah, because number 2 and 3 are the ones for the exam. Okay. You can start these now. No, A, AB, AB, A. Have you seen this method before?
Yeah.
Ah, you like it? 5 or more, you use this one. But 4 or less? No. Okay. English. Jerry, English. Bruce only likes English in class. Right, Bruce? Really true story. No. Now is working time, so I want you to do these questions. Do you know which ones? Do you? Which ones? A? You know? Okay.